So we are starting now the last session of this intense day with two talks about SonoAVC that will be presented first by Jairo, who is, as I said before, our chief embryologist, and he is he's been working for the past 12 years on trying to find out what follicular size is the best to predict mature oocytes. And the second by Adela from the radiological point of view. So,
thank you. First, thank you again for coming. It's a real pleasure for us to show our work. My talk focuses on optimization of ovarian stimulation by three-dimensional ultrasound and SonoAVC. The learning objectives of my talk are very easy. First of all, to introduce volume as a measurement parameter of follicle. Second, I want to show you the relationship between follicular volume and oocyte maturity. Traditionally, follicular growth has been evaluated manually by measuring the two largest diameters of each follicle using transvaginal ultrasound. However, this technique is not accurate because it has a high rate of inter- and inter-oocyte variation and can be a time-consuming process in patients with many follicles. With the development of 3D ultrasound and the improved image quality of ultrasound devices, technology has been developed that is able to automatically measure follicles. In 2007, Rain Fanning started to show the possibility of automatic follicle monitoring, and our group has demonstrated the feasibility of using this automatic follicle monitor in clinical practice. As you know, the software developed by General Electric called SonoAVC makes it possible to measure follicle automatically using 3D ultrasound. We first acquired a three-dimensional volume. I think this is the two words that you must say in this talk. And when the limit of the ovary calculate this volume and the toes of the bottom, and the software identify each of the follicle unit found in the ovary. I want to draw your attention to the fact that the follicular are not the spherical structure. They rather follicular have irregular shape that adapt to the structure of the ovary as the ovarian stimulation progresses. Once the software identifies all follicles, a report is generated showing the three largest diameters of each follicle, the mean of this diameter, and a new parameter, which is the follicular volume. And all this just in a couple of minutes. The system has this limitation and does not always produce quality image and well-defined follicles as this. It is important to validate the data obtained in the SonoAVC report. The tool for the optimization of the result will be discussed by Dr. Rodriguez in the next presentation. Sorry. All this article has studied the relationship between follicular volume and diameter in different aspects. The correlation between follicular volume and diameter, the relationship between real volume and volume measured by SonoAVC, the feasibility of automatic measurement, and the relationship between follicular volume and oocyte maturity. In summary, it has been clearly shown that there is a good correlation between manual and automatic measurement. Let me say, with automatic system, there is less intra- and inter-observer variability, and the volume measured with SonoAVC is similar to the real volume of the follicle extracted of the F retriever, or the day for retriever. So, I will speak about follicular volume around these three questions. Why use follicular volume? How can we use follicular volume for ovarian stimulation? Or could follicular volume replace follicular diameter in clinical practice? This slide is just to show you that if we have a sphere and ellipsoid, the mean diameter in two dimensions can be the same, but with very different volume. This corroborates the idea that 3D is more accurate than 2D because it has the third dimension or dip of the follicle. As you may have observed when performing a 3D reconstruction of a stimulated ovary, or sensed when performing a 2D ultrasound of follicles are not spherical structures. Therefore, extrapolation to geometric figure, as we do when measured diameter, can lead to considerable inaccuracy. Peter told this morning about the pixel, but I think it's important to refresh this concept. I will speak about, I will try to explain how we can increase accuracy with digitalization. The pixel is the basic unit of the digital image, and if we have a reference measurement, such as resolution, we can calculate the area that a pixel occupies. Once we know what area a pixel occupies, we can calculate how many pixels fit in a given structure, and in this way, determine more precisely the real area of any digital irregular structure. The representation of the pixel in 3D is the voxel. When acquiring a volume, the ultrasound device acquires several 2D images, and knowing the distance between each of these images, calculate the voxel. By adding up the number of hypocogenic voxels, you can calculate the exact volume of each follicle. This is one of the reasons, theoretically, the SonoAVC volume more accurately represents the real follicular size. This was the theory. Now let's apply this theory to the real life. We ask two fundamental questions. Is follicular volume, as measured by SonoAVC, a better predictor of oocyte maturity than mean follicular diameter? Which is the minimum follicular volume measured on the day of ACG administration that will most likely convey a mature oocyte? Our team has been working on this since 2009, and we have come up with some interesting results that will show in your rest of my talk. In our first paper, we compared the 2D diameter obtained manually, the automatic diameter of the follicle on the day of trigger, and the follicular volume. We assumed that bigger follicle contain mature oocyte, and we assigned the mature oocyte to larger follicle. You can see here the distribution of immature oocyte in blue and mature oocyte in green, according to the follicular volume. There is an overlap between size of follicular containing immature and mature oocyte. This is the region of interest to calculate the minimal volume corresponding to mature oocyte. You can see the same graph for the mean of 2 graded diameter by SonoAVC. This one is the graph for the mean of 3 diameter. And finally, this graph represents the manual measure the two greater diameters. Using this number, we construct a rock core. This graph represents the probability of true positive and the probability of false positive. We can see in blue the follicular volume, in green the mean diameter, the two greater diameter, in yellow the three diameter, and in red the manual mean diameter. ROCAR allows us to decide which of these parameters is most accurate to determine the cutoff between immature and mature oocyte. The area under the curve closer to the unit will be the best parameter. As a result, we found that follicular volume is the best parameter to predict mature oocyte. In a subsequent article published in 2016, we studied more precisely the minimal volume on the days of trigger associated with mature oocyte using linear regression. Since in our FIVAP paper, we estimate that a volume of 0.6 cubic centimeter on the day of trigger was associated with mature oocyte, in our second paper, we use different cutoff points in the range between 0.5 to 2 to better estimate the relationship between follicular volume and mature oocyte. As a result, we obtained that 0.65 of volume is the minimal volume that can most accurately generate mature oocyte. The cutoff point is not an on-off switch. We can modulate the chance of obtaining a mature oocyte. If we increase the minimal volume, we will have a better chance to obtain a mature oocyte, but we will probably increase the day of stimulation. On the other hand, if we decrease the cutoff point, we increase the chance of obtaining immature oocyte. It's a balanced decision. And with our experience, we have determined that volume greater than 0.7 cubic centimeter is the most appropriate value. To validate this concept of minimal volume, we have conducted several studies. In 2009, we published this result using oocyte donors. In the control group, we used the standard criteria of the measurement of the largest diameter to decide the trigger day. And in the study group, we use volume as the criteria for the trigger day. More than 70% of follicle greater than 0.7 cubic centimeters, 0.6 cubic centimeters. Also, the number of mature oocyte was higher, we not found significant difference. This study was useful to validate the volume as a parameter for trigger. Mortinger, also in 2009, carried out a study comparing 2D versus 3D ultrasound in the decision to induce ovulation. The difference with our work was Mortinger used the diameter of the sphere obtained for the follicular volume. In 40 patients, separated in two groups, they obtained no difference in the number of oocytes, mature oocyte, and pregnancy rate. They did obtain difference in fertilization, which was higher in the 3D ultrasound group. It is true that the randomized control study published so far not show superiority of 3D over 2D, but we believe that the part of the problem is that in all these studies, diameter and not volume were used to decide the day of trigger. We also studied the percent of growing during stimulation, especially between trigger day and egg retrieval. This is very important in determining the chance that with an extra day of stimulation, the follicle could reach the size that we consider mature. In 2010, we presented this abstract where we showed that the average follicle growth was 39% independent of follicle size. With all this data, we have been able to come to the conclusion with regard to the use of follicular volume that follicular volume of 0.7 cubic centimeter has an 85% chance of having a major oocyte on the days of pickup. Follicular volume of 0.5 cubic centimeter has a good chance of exceeding 0.7 with an extra day of stimulation. Based on this data collected during more than 10 years, we come up to the new criteria for trigger based on follicular volume. At least 2 follicles greater than 2 cubic centimeters with more than 70% of follicles greater than 0.7 cubic centimeters. And now let's see how we use all this in clinical practice. This is a report we obtained with SonoAVC. This is the volume of the different follicle. This is the diameter of each follicle, the mean of 3 diameter, and this diameter that we normally use Mortinger is coming to the calculate the volume, the diameter of the sphere using the volume of the follicle. During stimulation, we can take data and analyze the growth of the follicle. This is the first case where we can see the follicular volume, and we can see this is the diameter, the manual diameter of the follicle. Using a conventional criteria, the patient is ready to trigger, but more interesting is if we look the follicular volume, this is the number that we expect to be a major oocyte, but more interesting is this follicle. This follicle with an extra day of stimulation is possible to be a major oocyte. This is the other ovary. It's the same. You have a different follicle, and I have a follicle with this volume. We decide to give one more day of stimulation, and we see that in theory we have increased the number of major oocytes, and the remaining follicle is the volume is not possible to be a major oocyte. The other ovary, and as a result of the pickup, we have the number of major oocytes that we have predicted. In case of few follicle, precision in the choice of the day of ovulation induction is even more important to maximize the stimulation yield. Of course, there are other stimulation parameters that must also be taken into account when deciding the trigger of the patient, such as the day of stimulation, the estradiol level, the progesterone, the endometrial, and above all, the clinical condition of the patient. To personalize stimulation, it is important to weigh each of these parameters according to the patient proportion cycle. For example, see if the patient is going to a fresh transfer or a freeze-all or PGT. In summary, and as a final message, I would like to say that SonoAVC is more accurate than manual method. SonoAVC is more efficient in time, and follicular volume best predict the number of major oocytes. Thank you for your attention.
Thank you, Jairo, for your